Yeah. So this is the point where we left last time, where we were seeing the Wireshark log and kind of the artifacts that the malware was trying to connect to a channel with name Nikki and username Mikey. So that's where we left. And today I will be going through the code analysis, and just let me kind of terminate the srvcp.exe. Yes, I'm sure like now the srvcp.exe is not running on my system. Let's quickly check it. Okay, yeah, it's not running. Okay, so the thing is, when I will be going to the code analysis, I won't be doing a through analysis of the code of the malware, because my plan is actually kind of on today's call. Just a minute. On today's call, I will be showcasing the basic overview of those two, like the IDA Pro and OllyDebug, and we'll be going through some of the functionality. We will see some of the functions which kind of the malware is calling. We won't go through the full details of those malware, because thing is, because I want actually not to invest full time in kind of doing the through code analysis of srvcp.exe, because that malware is kind of a basic one, the starting example. And like there are a lot of other samples that I will be going through, where I will do a deep code analysis, where you will see a lot of other interesting features. So I will be like kind of showcasing some of the features, that some of the artifacts that you can gather from the code analysis of this malware. And then for other malware sample, then where I will be like doing the code analysis, I'll be showcasing some other features of that. Okay, is that fine?
Yes,
Yeah,
okay,
bro. Yeah.
that's fine.
Okay, okay, great. Let's start. So I'll be starting up with the IDA Pro. So IDA Pro normally comes in a free version and as well as some evaluation version. So evaluation version is similar to the professional version, where you get all the features, but kind of it is kind of just for some limited trial. So I will suggest you guys go with the free version. But if you guys also want to test the evaluation version, because it's very powerful, it has a lot of like kind of inbuilt plugins. Like when you upload the binary, it will convert a lot of binaries, assembly binaries to human readable C language code. Okay, so what I normally do is the trick that, suppose you get hold of the evaluation version, what you can do is mainly maybe try to load in VMware and kind of just test it. And I'll just pause the recording. Okay, so this is the first logo that you will see of the IDA Pro. I'll just go and click, and now I'll go to the open over here and go to desktop, srvcp, srvcp.exe, open. So this is the first screen that you will see once you load, once you try to open a binary inside the IDA Pro. Okay, and kind of it will give you some basic details, like it will automatically check that this file is kind of a portable executable, window executable, and it will select that, and you just need to kind of click on OK, and it will load the malware inside the IDA Pro. It won't run that. For running that, you have to kind of click on the run button. So it will just parse the binary and show the assembly language to you. Okay. So this is how the IDA Pro looks like. It has completed the analysis, and kind of it is showcasing you the assembly language, the internal code of that malware. So as you can see, that there is something written as text dot text. So there are a lot of multiple sections inside the executable, like dot text, dot rsrc, the resource section, dot data. These all things we will be covering in much more detail later in this course. But for now, for this today class, I just want to give you an overview. So I'll just showcase you what all windows you get, you can see in this IDA Pro. So this is the IDA Pro code view where you can see the assembly code. Then something there is hex view, where you can see the binary in hex format of the whole exe file. And these are the export functions from where it starts executing the code. Then the import version, where it kind of, so this import version actually tells you that malware needs certain kind of functionality. Like suppose it wants to connect to the network and wants to connect to a particular IP address with some port number. So it would normally require window APIs. So those thing actually comes under wsoc32.dll file. That is a proprietary window DLL file. It gives you a lot of kind of functions that you can use. Like suppose the malware wants to connect to a particular IP address, it can call the connect function inside wsoc32. Then it can also get host by name. Maybe this you can convert a domain to an IP address and a lot of other things, or might be listening to a particular port number if you want to create a server, receiving the data, sending the data. So using just seeing this import window, you can get a pretty much idea what's the capability of the malware. So just seeing this, I can tell, okay, the malware has some internet functionality, and it has functionality like connecting to IP address. Maybe it is also starting a server that we saw when we ran the malware, it was listening on port number 113, and maybe then it is receiving some commands from the C2 server and sending some data outside to the malware attacker. Okay. And now if I just go through that, and even now here I can see that it also has the capability to kind of interact with the registry values. Like last time we saw that the malware was trying to create was having an auto persistence mechanism, and it was trying to make an entry in the run registry key. So from here I can see, okay, this malware has some functionality where it is trying to set some value in the registry. And then there is some DLL file called CRT-DLL that we will be seeing in much more detail when we will be kind of analyzing the malware code. The reason is because CRT-DLL file actually gives a lot of functionality to the malware, like fopen, as you can see in my screen, that by which you can open a file for reading or writing. So we will be seeing this. And why I'm telling this fopen, because last time I told you that there was a gus.ini file that we placed inside syswall64 to, and then the malware functionality was pretty much different. It was trying to connect to 6666. It was listening to trying to
Again,
connect on.
little disturbance is coming from your voice.
Okay. Is it fine now?
No, Pragyan. Shava, even are you able to hear the same disturbance?
Yeah, Sadeep, I can hear the disturbance.
Any improvement now? No?
Yes, it's clear.
It's clear? Okay, fine. Yeah, just let me know again if it comes back here. Okay, so yeah.
Sure,
So, yeah. So what I was telling is like we will also see, we will try to see that if we can decrypt the gus.ini file. Like last time we put that file in syswall64 folder, and when we opened that file in Notepad, it was pretty much encrypted. So we will see like if we can decrypt that by doing a code analysis. Okay. So this all pretty much good information. I can get it from the import window, where I can see what all functionality this malware has. And now I will go to the another window over here called strings. Okay, so string window is somewhat here. Okay,
So what this actually gives you is like when the malware writer was actually developing the malware, so he might have wrote some lot of strings in that, maybe the comment or maybe the variable names and all, just to uh, kind of like suppose I declare a function call which try to encrypt the file. So maybe I will name that file as something as kind of encrypting function. So if we do a string analysis, like what all strings are contained in the binary of an exe file, so I can get a lot of good ideas that, okay, what all functions are there, or maybe what all ISCs are there. So suppose, just for an example, kind of this malware is trying to kind of do a auto persistence, like writing a key in the run registry key. So that path of the registry key would normally be there inside the malware binary. So by seeing the strings function, by seeing the strings of that binary, I can tell, okay, what are the registry path that the malware is trying to write to. So over here, I see a lot of things like, if you see in the screen, there are a lot of things like NHL, PWF, something AHKL. So I'm not sure what these things are, but kind of we will see that what it turns out to be when we were analyzing the code. So basically, these are some of the commands that you will see that is kind of encrypted and kind of that the malware will be decrypting in the runtime and kind of doing some further activity. So many times malware attacker knows that the malware analyst will try to run the strings command and kind of see the capability of the malware. So what they do is, like, most of the time they try to also encrypt the strings containing inside the malware. Okay, so like I can see some pretty interesting in string command like FTP. So it seems like the software, the malware might also be connecting, has a FTP functionality where it might be connecting to a specific IP address and transferring the files. So there are a lot of things that you can get it from here just by seeing the strings command. So later today, when I will be analyzing the another malware sample, that is brbot.exe, you will see that strings command, and I will run the strings on that too. And you will find that you can get lot of information just by doing a strings on a malware binary, that what are the activities that malware will be doing once it is running, like which registry key it will be accessing, what kind of IP address it will be trying to connect. So lot of details you can get just from the strings command. Okay, so let's quickly go to the IDA Pro view. And as I told, now I won't go from the start analyzing the code, but I will showcase some of the interesting code of this malware. And later, when we will be kind of seeing some other malware samples, I will be showcasing other functionality of those in the code analysis. So quickly, I will now go through this code and I will try to search if there are some strings that are available that the malware is trying to maybe load it into the any kind of registry or on the stack. Okay, so before that, I just want to ask you guys that I told that in the strings that lot of strings, it seems to be encrypted. So I just want to know from you all guys, there's a quick question that can you tell me what's the difference between encryption, uh, encoding, and obfuscation? Any idea?
Yeah, Pragyan. So encoding will basically use an algorithm which is like publicly available, sort of, which we can use to decode it ourselves. We don't need any key or anything like that. In
Yeah,
decryption and encryption, there are two types, symmetric and asymmetric. So
correct.
in that we use keys, uh, private keys and public keys.
Yeah.
So if it's a symmetric encryption, both the keys will be the same. If it's an asymmetric, the keys will be different.
Yeah, correct. Yes. Yeah, definitely. That's the correct answer. So yeah, encoding and obfuscation are normally, I will say, is almost similar. And kind of encoding, you don't need a key to kind of decode the stuff. And in encryption, normally you need a key to kind of decrypt that text in a human readable format. So yeah, that's the correct answer. So I will be now moving forward in this assembly code. and try to see if the malware is somewhere trying to access the strings, any other string. So we'll just go quickly. So a lot of things will come later where I will like tell you, okay, for this, like suppose for this function, so there's a function called sub 4012c6, so there will be like I will let you know like what these terms are. So this all things you will see whenever you are going inside a function. These two lines you will see for every kind of functions. So I will tell you what that means later in this course. And apart from that, these are some of the things. I will just tell you that these are some kind of variable that it is initializing, and these are the things that is actually related to setting up the stack for the functions. Okay, and now something that I want to specify now itself is that you see it's a kind of subroutine or kind of a function, but it doesn't have a human readable name. Okay, so thing is like when the malware writer was actually trying to compile its binary, what it does he did was like he tried to remove the symbols from the malware assembly from the malware binary. So what happened, because when he removed the symbols, the original name of the function won't be showing up over here. But so what happened is now IDA Pro doesn't have the original name of the function. So what it does is like when the functions the point from which when the code of the function start, so it just named that function as sub and the offset from where the function code starts. So as you can see, the code of the function start from 402.126.12c6. So it names the function as sub underscore 402 401.2c6.
Is
So
this the address of entry point, Pragyan?
no, this is not the address of the entry point. So that's something different as of now. This is some, I'm just showcasing some of the interesting function now of this malware. And later for other sample, we will start analyzing the malware directly from the entry point. Okay. So
So, but address of entry point is the point from where the code starts, right? And you
yeah.
said that this is where the code starts from.
No, this is
4021.
yeah. This is something. This is one of the interesting function that I will be looking to, and this function I want to tell is the code of this function actually start from this. So this is one of, maybe like suppose you have a main function in your code, and there are a lot of different functions that you are calling like A, B, C, D. So this is one of the kind of uh, function inside that. Like suppose the A function, like suppose it is doing. So suppose this is a function that does some decryption of some of the string. So I can tell this is a decryption function, and because the symbols were removed when the malware writer was compiling the binary. So what happens now, the IDA Pro doesn't have the proper name of the function. So what it does, it just, when it sees that a function is getting started, because the function, when a function gets started, normally we have this kind of starting assembly instructions. So it records the offset and just name that function as sub underscore 4021c6, the location of the offset from where the original code of that function starts. Okay, so and also later what I will tell you that, okay, once we have analyzed the code of this function, and we suppose we found, okay, this is the function that does some encryption or decryption, we can highlight this line and just press N, and I can rename this function as something readable to me. Like suppose I can type as decryptor. So when I'm analyzing the code again, I can tell, okay, this is a decryptor function that has already been analyzed by me. So that we will do once we kind of make sure, okay, what this function is related to. Okay. And apart from that, there is another thing that I will tell you is like when you are in this mode where you are seeing the assembly code, and if you just press space over here, so it will give you the graph of like how the call is being made. So you can see that the graph is being made, and something like if the kind of the condition is like correct, then it's shown by the green line. If it is a no, it's shown by the red line. And you can like kind of go back from the graph mode to the textual mode just by again pressing the space over here. Okay, so if I just press the space, I again go to this thing. And the other thing, there are a lot of other functionality in the IDA Pro that we will be seeing once we kind of achieve that, like kind of going back and forward in the code. Like suppose I went to some other functions and then some other function, I want to again go back to the original function that was calling the sub function. So I can do that. There are some buttons known as going backward and forward, similar like of functionality we have in our browser. So that we will I will be showcasing later in this course. So kind of I'm going forward now in this function. I'm just trying to see if there are some interesting activity that is happening. Okay. Okay. So over here, the thing is I'm seeing some of the strings that are getting passed to. So are you guys comfortable with the assembly language as of now? Any like you have ideas about what all registries are there? What kind of storage point are there in the CPU, like EDX, EDI, and all?
No, Pragya.
Oh, okay. Okay, fine.
No, Pragyan.
Okay, fine. So thing is like, don't worry about that kind of, as I told, this is just an overview of the code analysis. I will go through the basic assembly instruction, like what this push offset something means and what this call something this means, or MOV command means. So I will go through that in much more detail. Like I will cover all the commands, most of the command which you will be seeing during the code analysis. Just this class is just to give you an overview of the kind of the taste of the assembly language, like how these all things is viewable in IDA Pro. So I will just give you an overview kind of the assembly language for, over on this call. So what is happening is, like as you can see, there is something called push. So this is one of the command that actually like you can, so there's something called memory called as stack memory. Okay. And in the stack memory, what happens is like it's so you guys might have ideas about the stack, right? Correct?
Yeah, Pragya.
Yeah, so stack is something like suppose you have a bookshelf and you keep one book after one another, and kind of it follow the rule called as LIFO, like last in first out. So the topmost book you kept, the last time you kept, you took it the first time, so it's last in first out. So that's kind of a memory segment that is in your RAM memory, where you have something a similar structure called stack, which follows the rule called as last in first out. So sorry. Okay, so what happened is in the stack memory, what this code is actually doing, it is pushing this kind of string, NHL star PWS. I don't know what this string is, but I will try to see what this string tells us when we analyze the code. So what it's doing, what it is doing is that there's an empty shelf. So just imagine like there's an empty book shelf, and this command push and some string it is pushing to that stack memory, and it is keeping that kind of string inside in that stack memory. Okay, now when I tell, okay, there's another push command that is storing another string, so that means this this string AHKL is kept above the string NHL star PWF. So is that clear to all of you?
Yes, Pragya.
Okay, so yeah, I understand like it will be somewhat difficult for you, both of you guys, to get hold of this. But as I told you, just an overview. I will go through that again later in the course in much more detail. So push command is something which kind of pushes the string to it can actually store any data. In this line, it actually storing some string in the stack. And what that is doing again is like it is calling a function. So with the call, it is actually calling the function 4021C6. Okay. So what happens is whenever, like suppose in a C program that you have written, whenever you call some functions, okay. So in next 2 minutes, I will be like kind of closing this meeting and we'll be starting that again. So what is happening over here is like, suppose you have written C program which has a main function, and it is calling another function called add or subtract. and you are passing some argument to the add function like a and b that contains the value 2 and 3, and it is returning you actually the addition of that number like 5. So what will happen is before the main functions called the add function with the argument 2 and 3, what it will do, it will push the uh, value 2 and 3 into the stack. You got it right? Am I
Yeah,
clear?
Pragya.
Yeah.
Got
Yeah,
it.
Okay.
Pragya.
Yeah. So once that arguments 2 and 3 are pushed to the stack, okay, then what will happen is like the function will be called, and that function, what it will do, it will fetch those values from the stack 2 and 3, and it will do the analysis. And then what will do, then when it is returning the value 5, what it will do is like there's a storage point in CPU called EAX register. Okay, it will store that 5 value inside that EX register. So normally what happens is like whenever so an overview is that whenever a function has been called, normally what is done is like the arguments are saved into the stack. Then when the instruction pointer or is inside the function, it actually pop those values. So there is a function called pop which actually pop those values from the stack, like 2 and 3 are given to the add value. And when the add has done some analysis like adding both the numerical value 2 and 3, the final result is stored in the EAX register. So the EAX, when the instruction pointer will be exiting the function add, so it will store the value to the EAX, that is the 5 value. So similar thing we will see over here. And so so what I'm doing right now, I'm stopping this share, and I will be kind of like restarting the session again in some time.